Hi guys, welcome back to Chem Talk. Today we are going to start our exploration of the atom and the parts that make up an atom by looking at a little history of how we came to our current understanding of the atomic structure. I think it's really important as we go through this that you understand that these discoveries that scientists made weren't out of the blue, that they actually built upon the work of other scientists who came before them. The other real interesting thing is that I think is when we start looking and talking about the subatomic structure of atoms, we realize that some of this earliest work was actually done by physicists and not chemists. So there's a tie between chemistry and physics. So let's go ahead and start talking about the developments that led to our current understanding of subatomic particles. The first person to actually kind of talk about atoms is a Greek philosopher by the name of Democritus, about 400 BC. And he was the first person to coin the term atom. He actually used atomus was his term. And at the time, they didn't have science. Okay, they were thinkers. So basically what he did was use logic to argue that matter was made up of these small, tiny, indivisible particles. Okay, so he believed that everything in the world consisted of these small particles called atoms, and that these atoms were indestructible, indivisible, and always in motion. What he thought was this: let's say we had some sort of matter. If we divide it in half, and then divide it half again, and divide it half again, and divide it half, and keep dividing it, eventually we were going to get to this small, indivisible particle. And that's what he called the atom. And the atom were not able to be broken down any smaller. Now, the only problem for Democritus was at the time Aristotle was the man. Everybody kind of followed his lead, and Aristotle disagreed with Democritus's ideas. So his ideas were almost forgotten for about 2,000 years. Okay, chemistry. Now, it didn't take us that long to start working on chemistry, but it took us a while. John Dalton was the first person who kind of revisited Democritus' idea. Okay, he reestablished the theory of that matter is composed of tiny, indivisible particles, or which we called atoms. And he developed what we call the atomic theory of matter. And the atomic theory of matter is made up of 4 points that you got to make sure you get these. Okay, and a lot of the points in these atomic theory of matter were based off of scientists who were working at the time, who came up with ideas that he incorporated. So let's take a look at these 4 points of it. First one, he said that each element is composed of extremely small particles called atoms, revising or bringing back Democritus's idea. The second point was that all atoms of a given element are identical to each other, but they differ from those of any other element. What he meant by this was that all gold atoms looked alike, but each gold atom was different than a silver atom, or an oxygen, or a nitrogen, or an argon atom. Every atom had its own unique characteristics and properties. Thirdly, he said that atoms are neither created or destroyed in any chemical reactions. Basically, the law of conservation of mass. Okay, he didn't come up with this idea, but he incorporated the law of the atomic theory of matter. And the fourth one was that a given compound always has the same numbers and kinds of atoms, meaning water, H2O, is always made up of 2 hydrogen atoms and 1 oxygen atom, or carbon dioxide, CO2, 1 carbon, 2 oxygen, or carbon monoxide, 1 carbon, 1 oxygen matter. So he can put these 4 ideas together to come up with the atomic theory of matter. Now, I would go ahead and pause the video at this point and copy these down. Alright, the next person to kind of contribute this was a scientist by the name of J.J. Thomson. He was a British scientist, and he is responsible or credited for discovering the electron. Okay, this is our first known subatomic particle. And he is famous for what we call the cathode rays experiment. Maybe you've heard of cathode rays from TVs. Not the newer ones, but the older TVs produce the image using a cathode ray. And what he did in his experiment was to shoot electrons through this cathode ray. And through this, and use of magnets, he discovered the electrons. And by discovering electrons, he kind of discovered the fact that atoms were not indivisible, but they could be subdivided. Okay, so the first of the subatomic particles, meaning smaller than atoms, subatomic, was the electron. Okay, and from this he developed what we call the plum pudding model. I don't know what plum pudding is, so I think of it as chocolate chip cookie dough. Okay, basically in the plum pudding model, what we see is that the negative charges, the electrons, are uniformly distributed in an atom's positively charged interior, meaning the electrons and protons, what we call them now, are evenly distributed with him. We know that's not the case, but this was the first really accurate model of an atom that came. Now, building onto this was a gentleman by the name of Robert Millikan, and he was an American scientist in the early 1900s, and he experimented with oil drops. He's known as the oil drop guy. Basically what he did was put drops of oil into this chamber that had positive and negative plates. And through this, he was able to measure the charge, or the numerical value of the charge of an electron, and also come up with the mass of an electron. He determined the charge of an electron to be negative 1.6 times 10 to the 19th coulombs, a very small number. Now, you are not going to have to know that charge. I'm just giving you it as an idea. He also determined the mass of an electron, which is 9.11 times 10 to the negative 28 grams. Really, really small. Nothing I'm going to test you on, but I just want to give you an idea on this. So he built on a work at Thomson. The next scientist to come around was a guy named Ernest Rutherford. And Ernest Rutherford is known for the gold foil experiments in the early 1900s. Basically, Rutherford, his gold foil experiments led to the theory that an atom has a central positive nucleus surrounded by negative orbiting electrons. So and unlike Thomson's, Rutherford said the positive charge was in the center. Let's take a look at the gold foil experiment. Basically what he had was what we call an alpha particle emitter. All alpha particle is basically a helium nucleus, 2 protons and 2 neutrons, and he shot it at a sheet of gold foil. And what he found, for the most part, the particles went right through, but occasionally, as we can see here, they bounced back, and this bouncing back was a really exciting point for him. His famous quote is, "It was as if you fired a 15-inch shell, really big bullet shell, at a sheet of tissue paper, and some of it bounced back." Imagine that, shooting a big shell and some of it bouncing back. So what we can see in this diagram is most of his alpha particles went through, maybe slightly deviated, but occasionally one would bounce back, and this bouncing back was the amazing part to him. Okay. From this experiment, he proposed that all of an atom's positive charge, as well as most of its mass, are concentrated in the atom's core, the center of it. And he called this the nucleus. Okay, and around this nucleus, he had the electrons. So they weren't mixed together as Thomson, but they were found in 2 distinct layers. So here's our central nucleus here. Then outside of it, we have the electrons. So we got the next model. From him, came Niels Bohr. Niels Bohr worked with both Thomson and Rutherford, so he had a really good understanding of him. He was actually, you can see here, a contemporary of Einstein. This is the two of them talking about quantum mechanics. Very intelligent man. Okay, so he applied what we call the quantum theory to Rutherford's model of the atom and came up with what we call the Bohr model. And the Bohr model is what we call a planetary model. Think about the planets rotating around the sun in a distinct path. Well, he said electrons did the same thing. They went around the nucleus in defined paths or defined orbitals. Okay, so in Bohr's model, the electrons move in definite orbits around the nucleus. We can see it down here drawn by these white lines. Here's the nucleus with protons and neutrons, and then we have the electrons going around the different orbitals. Okay, and these orbitals are what he called energy level, are located at certain distances from the nucleus based on the amount of energy it had. Now Bohr got it really close. He wasn't perfect, but close. We often will use his model when we talk about chemistry. It's not wrong, it's just not quite complete. Our current understanding of the atomic model, or model of the atom, comes from 2 scientists, Schrödinger and Heisenberg. In the 1930s, they argued that electrons don't follow these predetermined orbitals around the nucleus. Okay? Instead, what they said is they used the principles of uncertainty and probability to predict where electrons might be at any given time, and we get these different orbital shapes. Okay, and this is what our current understanding of the atom looks like. Now we're going to get into talking about these guys a little bit later on in this unit, so I don't want to spend a whole lot of time. But here's what I want to do for a review. You need to know the basics contribution of each of these scientists. So let's review real quick. Remember, Democritus, the Greek philosopher, first person to use the term atom, that there are these indivisible particles. Dalton came up with the atomic theory of matter. You should know all four parts of that. Thomson gave us our plum pudding model. He was the first person to discover one of the subatomic particles, and that was the electron. And this demonstrated that atoms weren't indivisible, but rather had some sort of substructure. Millikan built on Thomson's work and determined the charge, numerical value, and the mass of an electron. And then Rutherford came by and said that an atom has a central positive nucleus, which is surrounded by these negative orbiting electrons. Bohr gave us the Bohr model, which built on Rutherford's, and said that the electrons flow around the nucleus in these defined paths. And then finally, Schrödinger and Heisenberg used the principles of uncertainty and probability to predict where electrons might be given at any time. This is our most current understanding of the atom. Okay, guys, so from here, we are going to start looking at these subatomic particles in more depth. The electrons, the protons, the neutrons. So join us next time when we start looking at atomic structure in detail. I will see you in class, guys. Take care.